All right, so in this video, we're going to go through some examples from the notes we just talked about. And remember, the number on the inside of the parentheses is the horizontal shift. We usually say A, and the number on the outside, we usually say is K, is our vertical. But it's important to pay attention to the signs right here. So we have a negative sign here and a positive sign here. So that means since there's a negative sign in front of the horizontal, it's going to do the opposite of maybe what our first instinct is on these problems. So without graphing the following functions, what type of shift of the parent has occurred? Write it in two different ways. Well, the first way is obvious. The -1 is on the inside, so that means it is a horizontal shift. So a -1 is going to take us right 1. Because remember, the horizontal shifts go the opposite way of our first instinct when we actually graphed them out in the previous video. And we have a +2 on the outside of the parentheses. The +2 on the outside is a vertical shift, and it just shifts all the y coordinates up 2 units. All right, so then that means the second way to write this is f of x, and we're going to assume the parent. Forgot if this is written in your notes or not, but we're just going to add this little information. We're going to say the parent function is g of x. It's not extremely important except for this, what we're about to do. So this is going to hold true for all the problems we do. G of x is the parent function. So this tells us the f function is just the parent function shifted right 1 and up 2. And you'll notice the second way we wrote it is basically identical to the original problem. Just the notation is a little bit different. All right, number 2, +10 is on the inside, so that's a horizontal shift. So that's going to shift us left 10 units. And you've got a -5 on the outside. On the outside is our vertical shift, so that's going to take us down 5. If you understand this part, you're in good shape. If the second part's confusing you, try to watch a couple more examples and try one on your own. But basically all we're saying is this new function is a translation of the g function. And we're translating that g function left 10, so that means there's a +10 on the inside, and we're translating it down 5. So there's a -5 on the outside. I would encourage you to pause and try some of these on your own. Number 3 can be kind of tricky. That +3 is actually on the outside. There's no parentheses in this problem, but that's because we're only squaring one thing. So the 3 is on the outside of the mathematical operation of squaring. So you have to think of it as we're squaring a value for x, and then we're adding 3 to it. So it's affecting the y values. So this +3 is on the outside. So since it's on the outside, it's a vertical shift, and it's just going to shift us up 3. So the new function is just taking the parent function, which is g, and adding 3 to all of its y values. And then finally, number 4, the +5 is on the inside of the mathematical operation of square root. So the +5 is going to shift us left 5. Or we could say f of x is the g function shifted left 5. All right, I'm going to do some practice graphing some of these problems now. Keep in mind there's a multitude ways to do this, but number 1 and number 2 are both quadratics, which means number 1 and number 2 both have the same parent function of y equals x squared. At this point, hopefully you know the 5 points, the 5 key points for y equals x squared are 0, 0, 1, 1, because when you square 1, you get 1, and 2, 4, because when you square 2, you get 4. And since there's symmetry to a parabola, we're going to have points on the reflected side of the y-axis. So again, this is the parent function that we're ultimately shifting on number 1 and number 2. If you understand how to graph the parent function and you understand the shift rules we just went over, the rest is going to be really easy to actually graph this new function. You could make a t-chart, but we don't need to do that because on number 1, that minus 3 is on the outside of the mathematical operation of a square. So since it's on the outside, it's going to shift all of the parent function points down 3. So literally that's all I'm doing from these parent function points. I'm just counting down 3 instead of making a table of values. So the one in red is ultimately our answer. I'll have a lot of students actually graph both, but just make sure you only connect the dots on the final answer. Number 2, the plus 2 is on the inside, so that's going to shift us left 2 units. It's a horizontal shifter. So again, we're going to take all of these parent function points and just shift them left 2, and then that's it. So this point right here shifted it left 2 and actually transposed it on one of the other dots. That's okay. So our translated function is right there in red. Name of the parent function is just a quadratic, and we described the translation, but we did it up there at the top. All right, let's do the same thing on 3 and 4. 3 and 4 both have the same parent function of y equals the square root of x. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And if you want to add one more, the square root of 9 is 3. So that's the parent function. And now we're just shifting that parent function. Number 3 is an up 1 shift because the plus 1 is on the outside of the square root symbol. And number 4, the minus 3 is on the inside. So that does the opposite of what we might think. So it's going to shift all of the points to the right 3. That one's a little bit off the graph there. I would encourage you to try 5 and 6 on your own. pause the video, and I'm going to show the answer here in just a couple of seconds. So there's the answers to number 5 and number 6 with the corresponding shifts there as well. If you want to practice a couple more, here's 7 and 8, and I'll show those answers here in just a few seconds. And there's 7 and 8.